Okay, we're going to start the course with section A3, which is at the back of the book, if I remember correctly. It's called Polynomials and Factoring. Now, I'm aware that many of you have seen a lot of this material at the beginning before. I beg of you, please do not go into this with the attitude, no, I know this already, I don't care. No. Pretend like you've never seen this before, work very, very hard, and get better at it. Even if you think you already know it, pretend you don't, do all the work and get better at it. Okay? My whole point in this course is to get you ready for calculus. And you've got to know everything in pre-calculus off the top of your head, okay, to do well in calculus. That is always the problem with students in calculus. They don't get stuck because of the calculus. They get stuck because they don't know the stuff from the semester before, which is this course. Okay, so please, I know what I'm talking about. Okay, now in this section, there's a lot of stuff in this section, but I'm only going to focus on the factoring. So you should look in the other section at other stuff, and if there's something you don't quite get, you can always ask me about, but you should be looking at other stuff. Okay, so the definition here, the paragraph, I say, a polynomial, I've underlined the word because that's what I'm defining. It's an expression with real number coefficients and positive integers for exponents on the variables. Okay, typically we use x, but it doesn't have to be an x. It says real number coefficients. What's a real number? It's pretty much any number where you're not dividing by 0, so 3 divided by 0 is not a real number. Or taking an even root of a negative number. So the sixth root of -5 is not going to be a real number. The square root of -2 is not a real number. Pretty much everything else is. Pi is a real number. Square root of 7 is a real number. Pi squared plus square root of 13 is a real number. Okay, so it's a polynomial is an expression with real number coefficients and positive integers for exponents on the variables. So basically a polynomial is a real number plus a real number times x for the first, plus a real number times x squared, plus a real number times x cubed, and you go until eventually a real number times x to some power. Right? You have to stop somewhere. You don't go on forever. So you put a real number here, they can be positive or negative. And notice the exponents on my variables, 1, 2, 3, they're positive. Now you can think of the number here by itself without an x, you can think of that as x to the 0 if you want, because x to the 0 we interpret as 1. But right, I just think of that, that's a real number x to the first power, second, etc. That's what a polynomial looks like. Now I want you to know, this isn't called an expression. It's not just polynomials that are expression. I put it in the notes here. Note the difference between an expression and an equation. Right? So for example, if I had a plus b over a minus b, now that's not a polynomial, plus I have two variables. Right? That's an expression. Okay? If you set it equal to 7, now it's an equation. Okay? So let me go back to what I had before. So if I had x squared plus 5, that's a polynomial. That's an expression. If I set this equal to something, now it's a polynomial equation. Okay, that's the difference. An expression isn't set equal to anything. Okay, so we need to go through some vocabulary here. And I made a table. Now you don't know the names yet. That's why we're going through it. So I have the table here that's in your notes. So I have the polynomials are listed here. We're going to find the degree of the polynomial, the name of the polynomial by its degree, and then the name of the polynomial by its terms. And again, we haven't defined any of that yet, but we'll go through it. Okay, so we have all these. Well, first of all, do you agree that all these are polynomials? Right? Real number x to the 4th minus real number x squared plus real number x. Pi cubed. Pi is a number. Pi cubed is a number. Right? That's a real number x. Root 2, real number x squared plus real number x cubed. They're all polynomials. Okay? Now, the first thing we're going to do is figure out the degree of a polynomial. The degree of a polynomial is the highest power that appears on the variables. Okay? All right, so it's just the highest power of the variable. All right, so what's the degree of this first polynomial? Well, the highest power on the variables is 4, so that's degree 4. We're just going to continue down with that. What's the degree of this second polynomial? Now be careful, right? The highest power on the variables is x to the 1st. That's degree 1. The 3 is on a pi. Pi is not a variable. Pi is a number. Okay, so that's not that doesn't count, right? It's only the variable, the powers on the variables. What's the degree of this one? 2. Now what about the 12? See, there's no x. But I mentioned a second ago, the constant term, you can think of that as being times x to the 0. So the degree of this polynomial is actually 0. So, so if there's no x, if you just have, like 12, if it's just a real number besides 0, we'll say degree 0. The number 0 polynomial doesn't have a degree. And then the last one, the degree is clearly 3. Okay. Okay, so let's talk about the names here by degree. So notice I have one of 0, 1, 2, 3, 4. I listed all different numbers here so we can talk about the names. Well, let's start with the lowest degree. So if you have a degree 0 polynomial, it's just a number. We call that a constant. Okay. So just a constant has degree 0. Again, except for the number 0 does not have a degree. It's still called a constant, but it technically doesn't have a degree. Okay, now degree 1 polynomials, we call those linear. Linear. So this is a linear polynomial. This is a constant polynomial. Now degree 2, we call quadratics. Quadratic. And then degree 3, third power, is a cubic. C-U-B-I-C, cubic. Along those same lines, degree 4 is a quartic. Now, I didn't put degree 5 up here, but it shouldn't surprise you. Degree 5s are called quintic. And once you go past 5, there are probably specific names, but usually you just say polynomial at that point. So these are all polynomials. Okay? But make sure you know the names. Because, I may ask a problem or test, or the book may ask a problem that says, give an example of a cubic that la la la, so you have to know cubic is a degree 3 polynomial. Okay? So, constants, linear, quadratic, cubic, quartic. And again, degree 5 is called a quintic, Q-U-I-N-T-I-C. Okay? So now that's the name based upon degree. Now, there's another way you can name polynomials, and that's by the number of terms they have. Now, I've kept these pretty simple here. Okay, notice both of these have one term. Right? It's just one thing, one thing. And these have 2 terms, and this one has 3 terms, right? 1, 2, 3. Okay, so what about polynomials that only have one term? Remember, poly means many. So polynomials, like things with many terms. But if you only have one term, we call that a monomial. Monomial. Oops, I spelled it. And this one too. Mono meaning one. Right, mono. Like a monorail. The one rail. Okay, monomial. Now what about with 2? It shouldn't surprise you. A polynomial with 2 terms is called a binomial. And this is a binomial as well. And the top one, therefore, is 3 terms, is a trinomial. Usually you don't see ones with 4 terms. I don't even know what they would call one with 4 terms. Okay? And notice, so you can mix and match, right? This is a trinomial that's quartic, that's a binomial that's a linear, that's a binomial that's quadratic, right? A monomial that's a constant, a monomial that's cubic. So you can mix and match. Okay, so there are some definitions for you. Okay, again, you have to know, as science majors, you have to know definitions just so you can communicate. Students will say, okay, the thing that with the x, and you set it equal to something, and it was the other thing. That tells me nothing, okay? You have to know your vocabulary. Okay, so the next vocabulary word, which cracks me up, that when I ask students the definition, they sit there and stumble. They don't know it, but they've been seeing it in algebra problems for years. And that's factor. You see this all the time. Factor the following. Factor the following expression, or solve the equation by factoring, which we'll do examples of later. And I'll ask the student, what does it mean to factor? And they don't know. Okay? There's your definition. To factor an expression or a number means to write the expression or number as a product. So I say here, notice 8 is 2 times 3 plus 2. That is a true statement. That's 6 order of operations, multiplication before the addition. 6 plus 2 is 8. That is a true statement. have I factored the 8? Have I written 8 as a product? Okay? No, order of operations, I have a product and then a sum. This is really 6 plus 2. I've written this as a sum, not a product. This is not factored. Right? But notice when I write 8 is 2 times 4, have I factored the 8 now? Yes, because I've written 8 as a product. Okay? So to factor means write as a product. That's all it means. Okay, so some common factoring formulas. Let me go ahead and write these. I'm going to write them over here just so we'll have them. A squared minus b squared is a plus b times a minus b. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. And then a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Okay. So these are some common factoring formulas that you need to know. And I say, let's verify that these formulas actually work by multiplying. Okay, now, do you agree that these are factoring formulas, right? Notice I have a squared minus b squared. This is a difference, this is a difference, this is a sum. But notice I have this difference written as a product. It's something times something. This is something times something. This is something times something. So the factorizations on the right-hand side, these are a difference going to a product, a difference going to a product, a sum going to a product. Okay, so these are factoring formulas. Well, so to check this, let me just take the expressions on the right-hand side and multiply them together and see that I get that, right? It's easier to do the multiplying. So let me do a plus b times a minus b. Let's multiply that together and show that we get that, and then we know they actually are equal. Now, I know you know FOIL, first outside, inside, last, but just to make it more general, because we're going to have to do that on the other two problems, remember when you have a polynomial times a polynomial, well, it doesn't even have to be a polynomial. When you have an expression times an expression with pluses and minuses, a whole bunch of things added and subtracted, what do? Use the distributive law multiple times. So basically you take each term here and multiply by each term here. So if you had 10, a factor with 10 things in it, something plus something plus something plus something, times another one with 10 things, what do? You take the first one here and multiply by all 10 over there. Take the second one, multiply by all 10. Take the third, multiply by all 10. And keep going. Okay, so that's what I'm going to do here. So I'm not going to follow the FOIL, even though you can. But FOIL doesn't work on the next two. That's why I'm explaining this to you. So if I do a times each of those, I get a times a is a squared. A times minus b is minus ab. So I did a times that and a times that. Now let me move to here. Now I need to do b times both of those. B times a, well that's plus ab. ba and ab are the same thing. B times minus b is minus b squared. And notice what happens. You have ab minus ab, which is 0. And you're left with a squared minus b squared, which is what we said it was. Okay, so again, what I did a times a and a times minus b. That's where that came from. And then I did b times a and b times minus b. And then those dropped out. Okay, so that's the general procedure when you have a long expression times another long expression. Take the first one here times everything, the second thing times everything, etc. Okay, so that we just showed the first formula does make sense. Okay, so let's do this one. So I need a minus b times a squared plus ab plus b squared. Now if I multiply all that together, I should get a cubed minus b cubed. Okay, again, you can't do FOIL because there's no, first is okay, outside's okay, but inside and last, yeah. Right, that doesn't make sense here because we have three terms. Right, so let's do what I said. I'm going to take a times each of those things. Okay? So a times a squared is a cubed. A times ab is plus a squared b. A times b squared is plus ab squared. Let me check myself. A times a squared is a cubed. A times ab is a squared b. A times b squared is ab squared. Now I'm going to do the negative b times each of those. I'm just going to continue here. So, and I'm writing the a in front of the b when I multiply, just so things will be in the same form. So negative b times a squared, that's minus a squared b. Negative b times ab, that's minus ab squared. And then negative b times b squared is minus b cubed. Let me check myself. So minus a squared b minus ab squared minus b cubed. Notice I have an a squared b minus a squared b and an ab squared minus an ab squared, and I'm left with a cubed minus b cubed. So that's that one. The third one works the same. I think I'll just leave that to you to do. Okay? So they do work. Now, I know you've seen this one when you had college algebra somewhere along the way, or even high school algebra, for crying out loud. But you may not have seen these. Now, remember, this is called the difference, because it's minus, of squares. This is the difference of cubes, and this is the sum of cubes. Notice the sum of squares, a squared plus b squared, is not up here because it doesn't factor. Okay? So be careful. It's a difference of squares that factors. Sums and differences of cubes will factor. Now, to be honest, I mean, here's what I do to remember those. Say a cubed minus b cubed. If I want to factor that, I'm trying to explain how I remember the formula. Here's how I remember the formula. So to figure out what goes there, drop the cubes. I get a minus b. Right? So if you just drop the cubes, you get a minus b. And then to get the other expression, I just look at this. Okay, I'm done with that. You square the a, you square the b, and you multiply those two together. I'm not worried about plus or minus, ab. Okay, so you square the a, you square the b, and you multiply them together. And every single one of these, there's always one minus sign on the right-hand side when you're factoring. Okay, so I'm not talking about this or this, I'm talking about over here. Right? I already have the minus there, so that's a plus and a plus. Notice that's that one. Okay, so that's how I remember the formula. All right, let me do it one more time. All right, so if I see a difference of cubes, how do you factor? Drop the 3's and you get a minus b. That's one of the factors. The other factor, you square the a, you square the b, don't worry about the minus. You multiply them together, ab. There's always one negative sign over here. There it is, and so that's a plus and a plus. All right, now let me do the same thing with the cube, the a cubed plus b cubed. Drop the 3's, you get a plus b. You square the a, you square the b, you multiply those together. Notice it's exactly the same. Now remember, there's always one minus sign that shows up here. It's not here, and you just have to remember it's the first one. Okay? Or just remember the b squared is always plus. Right? Since the minus is here, you know those are both pluses. Since that's a plus and you know that's a plus, the minus has to go there. Either way, make sure you know these formulas. Okay? It also would be helpful to recognize common squares and cubes. What are the squares? 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, etc. Now what about the cubes? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Okay, so you might want to get familiar with some of those common numbers. Okay, so let's do some practice here. It says factor each of the following completely. Okay, there are a whole bunch of examples here. So the first one says x plus y squared minus 121. Starting off kind of tricky. Okay. Now think about what we're trying to make these things look like. Something squared minus something squared. Something cubed minus something cubed. Something cubed plus something cubed. Okay? Now, this is all we've covered, so you know this has got to be one of these. Now the question, which one is it? Let me get something to drink while you think. Okay, well, notice this right here is something squared. Right? This is something squared. So it's not, doesn't look like it's one of these. It looks like it's going to be one of these. Now what you may want to do before you start getting into the formula is try to write it like that. Okay? So x plus y squared minus what squared? 121 is 11 squared. Again, that's all I was saying. You might want to start recognizing some perfect squares. And be aware, some numbers are perfect squares and perfect cubes, like 64. 64 is 8 squared, but it's 4 cubed. Okay, so be careful. Just if you get 64, don't fall, oh, it's a square, because it may be a cube. Okay? So this is like my a squared, x plus y is my a, minus b squared. Right? So how do you factor a difference? This is a difference of squares. Right? Well, what does the rule say to do? The two things that are being squared, you add them and then you subtract them. Okay? So what do? It's that and 11, so you add them, x plus y plus 11. And then you do x plus y minus 11. So this one is a little more complicated than your basic form because the a is a sum, is x plus y. Right? So when you have something squared minus something squared, what do? You add the two things here together, and then you say a minus b. So this is a plus b. This is a minus b. And it's factored. What does it mean to factor? Write as a product. That's what I have. This is the difference, right? Something squared minus something. This is a difference. This is a product. So that's how you do that one. Okay, so the next one says q to the 9th minus 27. Wow. Q to the 9th minus 27. Q to the 9th minus 27. Okay, well, what do you think? Well, is 27 a perfect square to match that? No. Is 27 a perfect cube to match one of those? Yes. So you can rewrite 27 as 3 cubed, right? 3 times 3 times 3 is 27. Now, what's going on here? These are supposed to be cubes. And this is to the 9th. Is cube, but can you write q to the 9th as something cubed? Be careful. It doesn't have to be a 3 sitting there. Okay? Remember, a base to a power, you multiply the power. So q cubed cubed, base to a power, you multiply the powers, which would be 9. Okay, so this one you have to think about. How are the, this is, q to the 9th is a cube. It's q cubed cubed. Okay, so now what does it look like? It looks like this. Right, so what's my a? Right, the 3's are these, right? 3, 3. But this is my a, q cubed, and b is 3. Okay, so how do you factor? Well, I'm going to tell you, drop the exponents. This will give me q cubed minus 3, just that and that. And once you do that, you don't even have to look at that, what we did, just do what I said before. Square that, q cubed times q cubed is q to the 6. Square the 3, 3 times 3 is 9. Multiply those together, don't worry about the minus. 3 times q cubed is 3q cubed. There's always one minus sign, it shows up there, so that's a plus, a plus. Then let me do that one again. Right? So once I wrote this as something cubed minus something cubed, to make it look like this is my a, and that's my b. So how do you factor? Well, you drop the cubes to just get q cubed minus 3. How do you get the other expression? You square that one, you multiply those two together. There's always one minus sign when you're factoring. It's already there, so that's a plus and a plus. And notice we have factored. Okay. 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 The next one says x to the 8th minus 1. Okay, well, it's a difference, so it's certainly not this one. Now, is this a difference of squares, or is it a difference of cubes? Because 1 is 1 squared, and it's also 1 cubed. Now, what about x to the 8th? Can you think of this as a square, or can you think of it as a cube, or can you think of it as both? Okay, so I'm going to think of this as 1 Well, I don't know yet. Either 1 squared or 1 cubed. We'll have to see. How can I rewrite x to the 8th as something squared? Remember, a base to a power, you'd multiply the power. So if I want that to be a square, it'd have to be x to the 4th, right? X to the 4th squared would be x to the 8th. So you could think of that as 1 squared. So I can do this as a difference of squares. So let's go ahead and finish this as a difference of squares, right? So this is like my a squared minus b squared. So a is x to the 4th, and b is 1. Right? So what do to do factor with the difference of squares? You add the two things together. That's x to the 4th plus 1, and then you subtract them. That's x to the 4th minus 1. Right? That's what the rule says. Right? When you have a squared minus b squared, you add the a and the b, and you say a minus b. You could do the same sort of thing I was doing here, right? Drop the squares, just drop the squares, that's one of them, and then the other one, change that sign. Change the minus to the plus. So if you drop the squares here, you get x to the 4th minus 1, change that to a plus, you get the other one. So I have factored x to the 8th minus 1 here. Now is that the end of the problem? It's not, because the instructions say factor completely. Okay. Now here we have a sum, but remember there is no sum of squares formula, and this is not a sum of cubes, because the x to the 4th is not a perfect cube. But what about this one here? This is another difference of squares. This is a difference of squares. So we can factor this now. So treat this as a completely new problem. I'm not going to do anything with, but that I've got to mess with. So I'm just recopying that. Don't take stuff out of your problem and then throw it back in later, right? You need to write out everything in every step. So how do you write this as a difference of squares? This is x squared minus 1 squared, isn't it? Right? Base to a power, you multiply powers. 1 squared is 1. So this is my new a squared minus b squared. So I'm just going to recopy that again. So how do we factor that? Well, if you drop the squares, you get an x squared minus 1, and then you're going to have an x squared plus 1, aren't you? Okay. And again, you can always recheck your factoring by multiplying, right? That's a good strategy too, right? You get x to the 4th minus x squared plus x squared is 0 minus 1. So it does work. Okay, are we done with the problem now? Well, no, because this is another difference of squares. Now that's a sum of squares, so that doesn't do you any good. So we need to do this one now, but that's easy, right? Right, it's something squared minus 1 square. So when you drop the squares, you're going to get x minus 1, x plus 1. Okay, now you can't do anything else. Right, that one took a little bit of work. The issue here, each step wasn't that hard, but you have to recognize that's a difference of squares, that's a difference of squares, that's a difference of squares. So there's 3 problems all in one here. Now let me go back to the original problem. I did it as a difference of squares. Could we have done this as a difference of cubes? Could you write x to the 8th as something cubed? Right, so x to the something cubed. Well, it wouldn't be an integer, right? Because 3 times what is 8? That's going to be a fraction, so that's not going to do us any good. Okay. Now, there may be some problems where the very first step is a difference of squares and a difference of cubes. What you should always use in that situation, if I remember correctly, is do the difference of squares. Because if you do a difference of cubes, you're going to get this funny expression here, which you may not be able to do. In general, you can't do anything with this. But if it's both, you might be able to, and you just don't recognize it. So if it's a difference of squares and a difference of cubes, do the difference of squares formula first, and then see what happens. Okay, so that one took a little bit of work there, right? I mean, this class is, souped up college algebra, so we're not going to stick to the baby problems here. Okay, so D says 125x cubed plus 8y to the 6th z cubed. Wow. Okay, my z's always have a little hash mark through them so they don't look like my 2's. Okay, so just if you ever see that, that's a z. Wow. Well, you know what it's going to be. It's a sum. The only one with the sum is the sum of cubes formula. Okay? So yeah, here we really need to write this as, write this as something cubed plus something cubed. So we need something cubed plus something cubed. That's what we need it to look like first. Right? Well, let's focus on the numbers first. 125 is what cubed? I mentioned this earlier. It's 5. 5 times 5 times 5 is 125. This is where I told you it's helpful to learn some of the basic squares and cubes, so when they show up, you know that's a perfect cube. That's a perfect cubed as well. It's 2 times 2 times 2 is 8. All right, now what about the x cubed? Well, that's easy. It's just going to be x, right? X cubed. Now what about, the same for the z cubed. But what about that y to the 6? How do you write y to the 6 as something cubed? Remember, the base to the power has to give me 6 when I multiply, and so I'm going to need a y squared, 2 times 3. Be careful, it's not 2 to the third power to get that, it's 2 times 3. All right, so this is my something cubed here, this is my something cubed here. Okay, so I've written it like this, and now I need to write it like this. Okay, well, remember, how did I tell you to get that first expression right there? Just drop the cubes. 5x plus 2y squared is 8. So that's that. Right, that's a cubed plus b cubed. I need a plus b. Just drop the cubes. And then how do we get the other expression? Square the first term. Now be careful. 5x quantity squared is not 5x squared. You have to square the 5. 5x times 5x is 25x squared. And then when you square this last one, 2y squared z times 2y squared z is 4. Y to the 4th is z squared. Right, 2 squared is 4. Y squared squared is y to the 4th is z squared. And then you multiply these together for the term in the middle. So that's 10 x y squared z. 10x y squared z. And remember, there's one minus sign, right? It's not there, it's here. And we factor. So that was not difficult, but it's tedious. It's easy to make a little mistake because there's a lot of variables. So you have to be careful. Okay. Let me skip E. I really should do A and B first. All right, let's skip down to the bottom there. Oh, no, that's all right. I'm going to the example at the bottom. We'll go back and do E. 2x squared minus 9x minus 5. And then this one is 12r squared plus 5r minus 3. Okay. Okay. Okay, so this says factor the following trinomials. I want you to realize all the problems we did before were binomials. They all had two terms. It was, something cubed plus something cubed minus something cubed, or something squared minus something squared. They were all binomials. Okay. Now this is a trinomial. This is a trinomial. So it's not going to be a sum or difference of cubes, or a sum or difference of cubes or difference of squares, because those were all binomials. These are trinomials. Okay. And I know you've done these before, and you may have 1,000 ways to do these, and that's fine. But you have to be quick about it, gang. You cannot spend 10 minutes, and I've seen students making a grid and putting the numbers and doing this and do all kinds of things, and 10 minutes later they finally factor. Gang, that's going to be the first step in a lot of the problems in this course and in calculus for those of you who are going on. You can't spend 10 minutes on a problem on the very first step. Okay? So if you do some strange algorithm to get your answer, that's fine, but you've got to be fast about it. Okay? Now, whenever I see a trinomial, I try to factor as, well, I had a student years ago call this a double bubble, and I kind of like that, because that's what it is. Right? So when I have a trinomial, well, we're trying to factor here, okay? So the product of these two has to be this. Well, if you do the FOILing, the first term times the first term, if you're putting from highest power to lowest power, is going to be 2x squared, right? How many things multiply to give you 2x squared if you're going to stick with integers? Well, a 2x and an x is the only possibility. Right? 2x times x is 2x squared. That's it. Right? Because 2 is prime. Likewise, what about 5? If when we factor, we mean stick with integers here, right? And 5 is a prime number, so it's you have to put a 1 and a 5. So it's either going to be a 1 and a 5 there, or a 5 and a 1 here. Right? I mean, there's only two choices. So now, let's look what I have here. So again, I haven't put the pluses and the minuses here. But notice 2x times x would be 2x squared. 5 times 1 is positive 5. So one of these is a plus and one of them is a minus. But now the kicker here is once you put in the numbers that you think from that one and that one, when you FOIL this out and do outside and inside, you have to get the 9x, the negative 9x. With the way I have the numbers here, there's a 2x and there's a 5x. Is there any, now one's going to be plus and one's going to be minus. Is there any way to get a negative 9 with a 5 and a 2? Even if, you had negative 5 and positive 2, you're not going to get negative 9 out of that. Okay, so that's just not going to work. I mean, you can eliminate possibilities. So what if I put the 5 here and the 1 here? So now I still have my 2x squared, I still have my 5. Now when you do the outside and the inside, there's 10x and there's 1x. You have a 10 and a 1. You ought to be able to get a negative 9 out of that. Right? And how do you need to do that? You need a negative 10 plus 1. Right? Now, so you see what I do here. I guess based upon that, I get those. Based upon that, I get those. And then you do the outside and the inside to try to get that. And again, because this is negative 5, I knew one was a plus and one was a minus. Notice if I had them the other way around, that'd be 10x minus x is plus 9x. That's not right. Now be careful. Just because those give you that and those give you that does not mean when you do the rest you get that. You have to check that. So let me check. 2x squared, negative 10x plus x is negative 9x minus 5. Now I know it took me forever to do that because I was trying to explain my thinking. Okay, so we factored that one. Okay, now what about over here? Now this one's a little more complicated because of the 12. Okay, because 12 isn't prime. Okay, so if we try to do the double bubble here, now the good news is 3 is prime. So I'm going to have a 3 and I'm going to have a 1. Again, it's a negative number, so one of these is a plus and one of these is minus. Okay. Now, how are we going to get a 12r squared? We're going to have an r and an r, but it's at 12. That's one of the factors of 12. We can do a 12r and an r for 12r squared. We can do a 6r and a 2r. We can do a 4r and a 3r. Did I leave anything out? No. Okay. So there's looks like 3 reasonable things to put 12r and r, 6r and 2r, or 4 and 3. Now, I personally try to avoid the extreme situation. I'm not saying that never works, but the numbers tend to get too big. For example, right? If I put a 12r here and an r here, what are you going to get when you do the outside and the inside? I'm going to get a 36r and a 1r. You're not going to get a 5 out of that. And you think, well, what if I switch them? Right? What if I put r here and 12r here? Well, I get a 12r and a 3r. You can't get a 5 out of that. Okay, so I just convinced myself that doesn't work anyway. But I usually don't try that one first because of that situation. Okay, now what about a 6r and a 2r? I'm just trying stuff here, 6r and 2r. Okay, notice again, big numbers. There's 18r and 2r. I'm not going to get a 5 out of that. Now what if I switch them and put a 2 and a 6? I'll put 2r and 6r. Notice I get a 6r and a 6r. You can't get a 5r out of that. What I mean is you can't add or subtract them to get a 5. Right? If you do 6r plus 6r, you get a 12r. 6r minus 6r, you get a 0. Okay, so I rule that one out. So it's left 4 and 3. I'm just going to put 4r and 3r. Now what do we get out of that? That's a 12 and a 3. You can't get a 5 from a 12 and a 3. Okay, I hope it works if I switch these. 3r and 4r. 3r and 4r. Notice the outside is 9r and 4r. You can get a 5 out of a 9 and a 4 by subtraction. Okay, so it looks like I finally stumbled upon the thing that's going to work, hopefully. One's a plus and one's a minus. I need a plus here, so the larger one needs to be plus. So the 9 and the 4, I need the plus on the 9. Now again, I think I've got it. Let me check myself. 3r times 4r is 12r squared. Negative 1 times 3 is negative 3. Please check the last term with the negatives, plus, positive and negative. And then I get 9r minus 4r is 5r, so I've got it. Okay. Now again, it took me a long time to do because I was explaining to you. Notice I wouldn't have tried the 12r first. Right? I would have tried this. I probably would have tried the 3 and the 4 first because those are the middle number. It's not like this number's crazy, right? Now, if this number had been like 15, I might have tried the 12r and the r first, okay? Because the number's so big. But 5 isn't a huge number, so it's probably more reasonable numbers here. So that's my thinking when I try these things, okay? But you have to be able to factor these trinomials quickly, okay? It's fine if you have a little algorithm, but you got to be fast about it. Okay, let's go back and look at that e that I skipped. It says a squared minus 3 squared plus 7 times a squared minus 3 plus 12. Now that's a big mess. Wow. Okay, now this one, it's it's a trinomial in disguise. Now, if you actually multiplied that out, combine like terms, you're going to have a big giant mess. That's not what we want to do here. We want to avoid multiplying things out. Remember, the goal is to factor, right, as a product. All right, so what we're going to do here is do a little substitution, and then it'll look more like something we can do. Because notice, it's a squared minus 3 squared, and then 7 times the same thing. Okay, let me call that x. So I'm going to let x be a squared minus 3. The only reason I'm able to do this is because it's showing up in both places. If this were a squared minus 3 and a squared plus 7, this little procedure probably wouldn't work. So let me rewrite this with my new variable x. I'm going to replace a squared minus 3 with x. So this is x squared plus 7x plus 12, isn't it? X squared plus 7x plus 12. Notice it's a basic trinomial. Let's factor this like we just did. So it's a trinomial, so I'm going to try the double bubble. So x squared, well that's easy, that's x and x. And the good news is, since these are both pluses, this has to be a plus and a plus. It has to be. Now what about factors of 12? We're in that same situation we had before. Factors of 12 are 12 and 1, 6 and 2, and 3 and 4. But think about it. Notice it's a 1 and a 1 here. Right? So how are we going to get a 7 out of a 12 and a 1? You're not. What about a 6 and a 2? You're not. So the only possibility is the 4 and the 3, isn't it? And that'll get you your 7, won't it? X squared, 3x and 4x is 7x. 4 times 3 is 12. Okay? So my original problem, a squared minus 3 squared plus 7 times a squared minus 3 plus 12, right? This factors as this, but what's x? X is a squared minus 3. So if I go back and put my x back, you get a squared minus 3 plus 4, a squared minus 3 plus 3. Right? I just put a squared minus 3 for x, a squared minus 3 for x. And notice what it turns out to be. If I simplify, that's a squared plus 1 times a squared. Notice it is factored. It's something times something. Okay. So this will actually, now that I see the answer, if I had multiplied this out, a lot of stuff would have dropped out and it would have been very easy to factor. But you don't necessarily know that before you do the multiplying out. Okay. So keep that in mind that sometimes, doing a change of variable, letting x be the complicated expression, rewriting it. Now it looks easy to factor, which it was, and then use this to factor that by plugging the x back in. Right? Then we have one extra step of simplifying here. Okay, so there's one more type we want to do here before we kind of summarize. So notice we learned how to factor binomials that were sums of squares, difference of squares and sum of difference of cubes, and we just practiced factoring trinomials. Keep in mind, every trinomial does not factor. Okay, we could easily make up an example that doesn't factor at all. So that was practice with ones that did. Now this next one, when I put in the notes, when I put a number in parentheses like that, that means I've copied the problem out of the homework set. Okay, it says 8x to the 5th minus 6x squared plus 12x cubed minus 9. And it says factor by grouping. Now I've added in parentheses, do two different ways. So we'll do this twice. So make sure you draw a line in the middle of the page, because we're going to do this twice. Notice this is a 4-term polynomial. Okay, so it's not a binomial, it's not a trinomial. Whenever I see 4 terms or more, I think about doing it by grouping. I may not be so generous on an exam and say do this by grouping. You should know there's a grouping problem. Now how does grouping work? You group terms together and factor those separately. Okay, so it's easier just to show you. Now I'm just picking something. I'm going to group these two together and these two together. I don't know if it's going to work out. I hope so. Okay, so let's look at these right here. And I want to factor this. So one thing we have not done yet is, first step in factoring is pull out the greatest common factor. We haven't needed to do that on any of the problems we've done. First step in factoring is greatest common factor. Notice I'm not trying to factor the whole thing right now. I'm just trying to factor the first 2 terms. Now what's the greatest common factor of 8x to the 5th and minus 6x squared? We'll focus on the number first. Well, 2 goes into both of those, so 2. And then x squared and x to the 5th, x squared goes into both. Right? X to the 5th is bigger than x squared, right? So you can't factor an x to the 5th out of x squared and still have a polynomial. So if I factor 2x squared out of those 2 terms, what am I left with? Here I have a 4x cubed and then minus 3. Check your factoring by remultiplying. That's 8x to the 5th minus 6x squared. Good. Okay, now let's do the same thing here. Now treat this as a new problem. Let's look at these two. What's the greatest common factor of these 2 terms? Well, this doesn't even have an x. So the greatest common factor looks like it's just 3, the constant. So 3 times. Now if I factor a 3 out of these 2 terms, I'm left with 4x cubed minus 3. Check your factoring by remultiplying. 12x cubed minus 9. Okay? Now, if this is going to work, we hopefully got the same factor on both. 4x cubed minus 3, 4x cubed minus 3. We got the same thing on both. So we're in good shape. Okay? Now, this may be hard to see what's going on. Let me write something simpler over here so you can see what we're doing. If I had an AB, let me say this again. If I had an AC plus BC, right? How would you factor that? Notice this is a sum. It's a product and a product, but it's a product plus a product, so this is a sum. So it's not factored. But how would you factor that? Notice the greatest common factor, there's a C in both of them. Couldn't I write this as A plus B times C distributed well? That's AC plus BC. Factor a C out of both terms. Right? There's a C here and a C here, so I can pull it out of both. Right? Factor the C out of here, you're left with A. Factor the C out of here, you're left with B. Right? Very easy. Right? I want you to realize that's what I'm going to do here. That's my C and that's my C. This is my A and that's my B. Right? I have A times C plus B times C. So if I factor that C out over here, notice what am I going to be left with? When I factor it out of here, I'm left with 2x squared. When I factor it out of here, I'm left with plus 3. Right? If you distribute, 2x squared times that would be this. 3 times that would be that. And notice I have factored the original problem. Right? I have something times something. Notice if I FOIL this out, right, that's 8x to the 5th there. That's minus 6x squared here, plus 12x cubed here, minus 9. So it does work. Okay, so let me write the answer here. Because again, we're going to do this another way. All right, that's the answer we got. Okay. Right? Jeez, sorry. Okay, I want to do this again, but let's group them a different way. What if I put the first and the third and the second and the fourth? Let me rewrite it that way. 8x to the 5th plus 12x cubed minus 6x squared minus 9. Right? So I just switched those. Okay? Because I wanted to group these two together and those two together. So we're going to try it a second way and hope we get the same answer. Okay? So let's do these two. Well, let's factor that. Now, what's the greatest common factor of 8 and 12? Looks like that's a 4. And x cubed and x to the 5th, that's an x cubed. Okay, so if I factor 4x cubed minus from 8x to the 5th, I get 2x squared, right? Right? And then here I get a plus 3, don't I? 8x to the 5th plus 12x cubed. Okay. Now again, right, let's pull out the greatest common factor here. Now we have to be careful. Well, let's just do it, and then if we need to adjust, we can adjust. Well, there's no x here, so the greatest common factor of 6 and 9 is 3. Now what if I pull out a 3 or plus 3? What am I left with? I'm left with negative 2x squared minus 3, right? Negative 6x squared minus 9. Now again, for this whole procedure to work, what I have here have to match, and they don't. What should I have done here instead? Right? I've got these extra negatives I don't want there. What I should have done is factored out a negative 3. So just keep that in mind. I mean, I knew that was coming, but if you just weren't looking ahead and you pull something out and they don't match, right? Well, they're off by a minus sign. So you can always go back and factor out the negative. So now when I factor out a negative 3, I'm left with 2x squared plus 3. Negative 6x squared minus 9. And now they match. Okay, now if we do the same thing we did before, I'm going to factor out the 2x squared plus 3 out of the whole thing. When I factor it out of here, I'm left with 4x cubed. When I factor it out of here, I'm left with minus 3, and that was the same answer we got before. So there's more than one way you can group these often. Now, if you try the 8x to the 5th, pairing that with the negative 9 and then putting those, I don't think you're going to be able to get it to work, because these aren't going to match up. But we did 2 of these that do work. Okay, so just kind of as a big review now of everything we've discussed so far, and then we'll do a couple more examples to finish. Steps in factoring polynomials. Number 1, factor out the greatest common factor. First thing you should do. Here's a polynomial. I want to factor it. First step, pull out the greatest common factor. If the polynomial is a binomial, see if the difference of squares, difference of cubes, or sum of cubes formulas apply. Okay? So if you have a binomial, we know what to do there. If it's a trinomial, try the double bubble approach. And if it's 4 more terms, do the factoring by grouping, or other methods we'll do later. Okay, so just there's a checklist for you. Okay, oftentimes I'll have students that are struggling with a problem, and I'll say, what's the first step in factoring? Grouping? No, right? You have to know the steps. Okay, it cracks me up in a math class. Oftentimes I will say to a student, step 1, do this, the student can do it. Step 2, do this, the student can do it. Step 3, do this, the student can do it, and they get the answer. And then, like I just said, here will be another problem. I don't guide them through the steps, and they're stuck on the first step because they don't remember the first step. Okay, you have to remember your steps. Okay, so we're going to do 3 examples here. So the first one says x cubed minus x squared minus 2x, and it says factor completely. Okay, so you don't just write it as a product and stop. You have to see if you can keep going. Okay, what's the first step here? Do we check for difference of cubes and difference of squares and that sort of thing first? No. What does the first step say? Factor out the greatest common factor. What's the greatest common factor of all three? When I say that, I mean of all terms. What's the greatest common factor of all three terms? X. So if you factor out x, you're left with x squared minus x minus 2. X cubed minus x squared minus 2x. Always check your factoring by remultiplying. Except for on the sum and difference of cubes. You don't want to do that. Okay. But it says factor completely, so now there's nothing you can do with the x, so I'm just going to keep copying that down. But what do we have here? Okay, we already pulled out, if you pulled out the greatest common factor correctly, the greatest common factor of what's left will be 1, which it is. Okay. So the next thing is this a binomial? No, so forget the sum and difference of cubes and difference of squares. But it is a trinomial, so that's what I'm going to try next with the double bubble. Well, this one should be easy if it does factor, because if the factors of x squared are x and x, 2 is prime, so the only factors are 2 and 1. And to get a negative 2 here, one of these is a plus, and one of these is a minus, so there's only 2 possibilities, either plus minus or minus plus. And the answer has to be negative, so I need a negative on the larger, so I need the negative here and the plus here. But let me check. X squared, negative 2x plus x is negative x, negative 2. And you can't factor any more than that. So that one's not too bad. But the key is doing it, first pull out the greatest common factor. Now it's an easy trinomial to factor. Okay, so B says 125 minus 5y to the 6, okay? Where do we begin? Right? First step says pull out the greatest common factor, which here is 5. 5 divides 125. So you get 25 minus y to the 6, right? Yeah, 5 times 25 is 125. 5 times negative y to the 6 is minus 5y to the 6. Okay, good. Okay, now, so the 5, we're done with the 5. We'll just keep writing 5. Now what do we have here? Here we have a binomial. A binomial. So, and it's a difference. So is it a difference of cubes? Is it a difference of squares? Now the y to the 6, you can think of that as y squared cubed or y cubed squared, can't you? Because base to a power, you multiply the powers. You get a 6 on both of those. So you can think of y to the 6 as a cube and a square. Either one. But which of these do you think we're going to use? Well, 25 is not a perfect cube. It's a perfect square. So I think we want to think of that as a square. So let me write it that way. So I'm going back to stuff we've already done. So this is 5 squared minus y cubed squared. Right. So I have something squared minus something squared. So this is difference of squares. So I'm going to keep writing my 5 from below. Now how do you factor a difference of squares? Well, remember, if you drop the squares, that's one of the factors. 5 minus y cubed. And then the other factor is change that to a plus. 5 plus y cubed. So again, this is reviewing stuff we've already done. It's just combining things. But here, once you pull out the greatest common factor, it's trinomial. You knew how to do that. Once you pull out the greatest common factor, is the difference of squares. We've done ones like that. Now this last example, wow, it looks like a horrible mess. But these are the types of expressions that show up in calculus, which is why I made this one up. So 2x times x minus 2 squared times x plus 3 minus x times x minus 2 times x plus 3 squared plus x minus 2 times x plus 3 times 7x minus 4. Goodness gracious. 2x, x minus 2 squared, x plus 3 minus x minus 2, x plus 3 squared, x minus 2x plus 3, 7x minus 4. Okay. Factor completely. Now what you do not want to do is multiply everything out. Think about how much work that would take. That's a lot of work. Now, you may say, look, it's already factored. I have something times something times something, and something times something times something, and something times something times something. This is not factored because you're subtracting and adding in between. It's something minus something plus something. Okay, this is not factored. It's not written as a product. Where do we even begin? Difference of squares or grouping? I mean, it's three things. Trinomial, what? Where do we begin? What does it say on the checklist? Is the very first step. Pull out, factor out the greatest common factor. Okay, so look at this expression, and this expression. Do they have anything in common? Right? They all have an x minus 2. Now that's an x minus 2 squared, but there's no square here and no square here. So the greatest common factor on that part is x minus 2. Now there's an x here and an x here, but there's no x here. There's an x plus 3 and an x plus 3 squared, x plus 3. So there's an x plus 3 in common, not square. So we can factor out an x minus 2 times an x plus 3 out of this whole thing. Oh, what about, no, 2, okay, I forgot to look at coefficients. That's the only one. So the 2, you can't pull out a 2, there's no 2 there. Okay, pull out the greatest common factor. Okay, so if we factor out an x plus 3 out of this term, it'll be gone. Now there's an x minus 2 squared, and we're going to pull one of them out. So we still have a 2x, and we still have an x minus 2. Right, do you see that? There's no 2x to pull out, so I left that here. The x plus 3 got factored out. This is x minus 2 times x minus 2. One of them got pulled out, so the other one stayed in. Okay, now let's go to this term. Okay, there's no minus x to pull out, so it's minus x. The x minus 2 got factored out. This is x plus 3 times x plus 3. One of them got factored out, so I'm still left with x plus 3. And on the very last term, the x minus 2 and x plus 3 got factored out front, so all I'm left with here is plus 7x minus 4. That's all I'm left with. So notice I now have this thing factored. It's not simplified, but I have something times something times something. So it actually is factored right now, but I expect you to simplify. Ugh, look at that. Okay, so I'm going to distribute here. So if I multiply 2x times x minus 2, that's 2x squared minus 4x. 2x squared minus 4x. Now be careful here, you have to distribute the negative sign. Negative x times x is negative x squared. Negative x times 3 is minus 3x. And I'm just left with this 7x minus 4. I put brackets here to indicate it's a whole big mess. Right, I put brackets to show I knew I was going to have to do something in there. Now I'm going to put parentheses now because I'm trying to simplify. Let's combine like terms. 2x squared minus x squared is just x squared. Negative 4, now the linear terms, right? These are the quadratic terms. Let's do the linears. Negative 4x, negative 3x is negative 7x, plus 7x is 0. That's gone. And I'm left with negative 4. So all that mess got down to x squared minus 4. How do we feel about that? Are we done? Hopefully you realize we are not done. The instructions say factor completely. This is a difference of squares. All right, this is x squared minus 2 squared. So there's one more thing we can do. I'll just cut to the chase. Well, let me go and write it out. This is x squared minus 2 squared, right? This term. Notice I keep writing the x minus 2x plus 3 all the way down. So how do you factor a difference of squares? If you drop the squares, you get x minus 2, and then the other factors, change that to a plus x plus 2. So notice you can actually combine these together. So that's x minus 2 squared times x plus 3 times x plus 2. I just combine those. That's a takes a long. Now notice where all the work was for writing. Each step was not that bad. Factoring out, and then that took some thinking, but once you did that, the simplifying was easy. It's just a lot of writing because there are a lot of terms. Okay, so that's section 8.3.